MAT video. Today we will now do question 1D of MAT 2007. So this question is quite complicated. You need to find a point on this circle that is closest to this circle. Well, you say closest, right? So you would do calculus, but in my opinion, we shouldn't do calculus. So you know the shortest path between 2 points is a straight line. Let's find out the centers on these two circles. And let's make the line y equals to mx plus c. So we substitute, so 5m plus c equals to 4 and m plus c equals to 1. That gives me a time to test out my shoelace method. So we will have 5, 1, 1, 1, and then we make a second matrix where we sandwich this in here. And then we make the shoelace determinant. You know the determinant for matrices. So 5 times 1 minus 1 times 1, you get 4. 5 times 1 minus 1 times 4 is 1. 4 times 1 minus 1 times 1 is 3. So m equals to this number divided by this number, 3 over 4. C equals to 1 over 4. Let's write down this equation because we will use it. So if you test this equation out, it will work for both. We can substitute this equation into here. So x minus 5 squared plus 3x over 4 minus 15 over 4 squared equals to 4. Now you expand the brackets, you get a rather complicated looking quadratic equation which will have two solutions. X equals to 33 over 5 or x equals to 17 over 5. Obviously, this coordinate is out of bounds for this circle, so we label it as rejected. So if x is 17 over 5, you will try verifying that y equals to actually, let's verify it right now. Y is equal to 51 over 20 plus 1 over 4 equals to 51 over 20 plus 5 over 20 equals to 56 over 20. Did I get it right? Yes, so I did get it right. Then we simplify. Job done. So our coordinate here is 3.4, 2.8. Incidentally, if anybody comes up to you and finds the shortest distance between these two circles, we can find this position. This is what's called a position vector. Now just for fun, we will find the same equivalent point on the other circle. This time I'm going to show the quadratic equation. X plus 1 squared plus 3x over 4 minus 3x over 4 squared equals to 1. Now look at it here. 25 over 16 times x minus 1 squared equals to 1 because we added the squares of these two. And x plus 1 squared equals to 16 over 25. X equals to 4 over 5, or then be 4 over 5, don't forget x minus 1, x equals to 9 over 5, or 1 over 5. Obviously, this will certainly not work. X is 9 over 5. Actually, it will. It also work when x is 1 over 5, but since this is out of bounds because it's actually the maximum, why don't we just find y? So, y minus 1 equals to 3 over 5 equivalently, and y equals to 12 over 5. So now we have, are you where I'm at? Okay, good. Now let's check our steps. Y minus 1 is 3 over 5. Oops, I made a mistake here. So we have our point 1.8, 1.6. So we have our 2 points. Actually, this is the solution to the equation. But if anybody else is looking for a nicer system wheel, you can find the equivalent point on the other circle. And that's it for circle problems today. See you in another MAT video.